Hello everybody, this is Willie Smith. Certainly miss you guys, would much rather be with you in person. But what I'm going to try to do today for the first time, and be patient with me, is do a YouTube video of the 4 types of factoring that we went over before spring break, and what I call the thought flowchart. And then I will do some examples of the odd problems, and your assignment will be to do the even problems. When you do the assignment, what most people have been doing is just taking a picture of the problems, in this case the even problems, on their phone, and then you can email them to me and I will try to address them as quickly as I can and let you know if you were doing them right or not and mark them as complete. Okay, first, the thought flow chart. 4 different types of factoring. I call it level 1. Always look for a GCF first. A GCF means your answer will look like the distributive property. If it's not a GCF, then you go to level 2 and you look and see, is it a binomial or a trinomial? If it's a binomial, it has to be a difference of 2 perfect squares, and a difference of 2 perfect squares looks like what I call special FOIL. So in this case, x squared minus 9 would go into x minus 3, x plus 3. Or in a bigger problem like 9x squared minus 25, that's a difference of 2 squares, a difference of 2 perfect squares. It goes into 3x minus 5, 3x plus 5. Those are the ones that most students are the most comfortable with. If it's not a GCF and it's not a binomial, then see if it's a trinomial. There's 2 types of trinomials. 1x squared types, such as x squared plus 7x plus 12, or something bigger than 1x squared, like a 5x squared type. I call that the harder math game, and we'll just use guess and check on that. Okay, I'm going to go to the examples. Your assignment is on Canvas, and like I said, I'm going to go through the odds with you so you kind of have an idea of hearing my thought process. Again, I also wrote it up here. Reminder, look for a GCF first, then look and see if it's a special binomial or difference of 2 squares. Look and see if it's a trinomial. See if it's a 1x squared easy math game, or if it's a larger than 1x squared, what I call the harder math game. Okay, example 1. I look and see, and they can both be divided by 10. So I'm going to pull a 10 out of both of them, or divide by 10, and they both share an m to the second. So that is my GCF. Most students like to think of this as division. You pull out or put the 10m squared or the GCF out front, and then whatever you get when you end up dividing is what goes into parentheses. We need a 2 and an m plus a 5, no m. The way you check this is you just distribute, and you should end up with the original problem. 20m to the third plus 50m squared. Like I said, you will do problem 2 on your own. You could either pause it and do problem 2 now, or wait till the video is over. Problem 3. Also I want to go back. You should always look and see what's in parentheses and if it can factor again using one of these methods. This cannot, that's when you know you're done. As you'll see later, there's times when this might factor again. Problem 3. They all can be divided by 2. And they all have a p to the third in common. So I can divide or pull out a 2p to the third. And then just divide, or times what? Divide by 2, you get 1. Divide by p to the third, you end up with a p to the second, plus 7p plus 2. Now here's where I'm referring to that there's a chance this one can factor again because it has our p squared, p, and a number. So I actually try the easy math game on it. Is there anything that multiplies to get 2 but will add or subtract to 7? And there is nothing, therefore you know you're done. But you should always look and see if the parenthesis can factor a second time. So you can go do number 4. Again, you could either print out this handout or you can use it on your own notebook paper and just do problems 2, 4, 6, 8, 10, 12, and so on. Number 5, I look and see, do they share a common factor I can divide by other than 1? And they do not. They don't share an A, so this one is not a GCF. Okay? Therefore, since it's not a GCF, I go to level 2, and I look and see, is it a binomial or a trinomial? This one is a binomial, so the only chance I have to factor this is if it's a difference of 2 perfect squares. A difference of 2 perfect squares, and it is. The a squared divides into a and a. The 16 divides into 4 and 4. In these problems, it always has to be the square root of 16. It can't just be anything that gets 16, like 2 and 8. It has to be the 4 and the 4, and it has to be an a minus 4 and an a plus 4. Neither one of those factor again, so I'm done. Number 6 or 7. I look and see, does 16 and 25 divide by something besides 1? This can only divide by 2, 4, 6, or 2, 4, 8, and 16. This can only divide by 5, so they do not have a common factor. They don't share a variable, so it's not a GCF. It is a binomial. So since it's a binomial, I look and see if it's a difference of 2 perfect squares, and it is. This must factor into 4x minus 5 plus 5. It does not matter which one you put first. As I said in class before break, I always put the minus first, but it does not matter. So this factors into 4x minus 5, 4x plus 5, and neither one of those factor again because they're not perfect squares, and there's no GCF. Number 9. I look and see if all 3 factors can be divided by something. They cannot, so it's not a GCF. I go to level 2. It's not a binomial, it's a trinomial. It's a 1x squared trinomial, so I try what I call the easy math game. The easy math game is what multiplies to get the third number, but will add or subtract to the middle number. What multiplies to get the third number, in this case 27, but will add or subtract to negative 6. My options are 1 and 27, 3 and 9, and which one of those can I get a 6 out of? It's 3 and 9, and specifically it's a positive 3 and a negative 9. So that's the game. Now the algebra is, this factors into a V and a V, and the 27 I'm going to split into a minus 9 and a plus 3. I FOIL to check. V times V is V squared. Negative 9V in the middle. Positive 3V, that's my O and I. And that gives me a negative 6V in the middle. And then the last term is my minus 27. Okay, I call that the easy math game. What multiplies to get the third number, but will add or subtract to the middle number. That's only true when there's a 1V squared there. Number 11. There is no GCF. It's not a binomial, it's a trinomial. So this is the easy math game. What multiplies to get 30, but will add or subtract to negative 13. The n squared has to be n and n. There's no other option. These two numbers have to multiply to get 30, but together when I FOIL, they have to give me a negative 13 in the middle. My options are 1 and 30, 2 and 15, 3 and 10, 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Which one of those can you get a 13 out of? This one's kind of tricky. Both of these you can get a 13 out of. This one by adding, this one by subtracting. The problem with this one is to get 13, they would have to both be positive. These would have to both be positive, which would add to positive 13. Or they could both be negative, which would be negative 13. Okay? 2 negatives when you multiply will give you a positive, so therefore that is the correct one. I want to mention this one. For this to be 13, I would have to have had a negative 15 and a positive 2. But when you multiply those, you get negative 30. Yeah, they give you negative 13 when you add them, but they give you negative 30. So that's why the 15 and 2 did not work. Okay, so this is going to be a 3 and a 10, both negative. N minus 10, N minus 3. There's my N squared. There's my negative 10N. My negative 3N is negative 13N and positive 30. Now, 13 is the toughest kind. First, I look to see if there's something I can divide them all by. This can only divide by 2. These guys cannot divide by 2, so I know it's not a GCF. It's not a binomial, so it's not like up here where it was a difference of 2 squares. And what makes this harder, it's not a 1n squared, it's a 2r squared, which means instead of this just being an r and an r, it has to be either a 2r and a 1r, or in some cases, and like in this one, it could be a 4 and a 1 or a 2 and a 2. This one has to be a 2r and a 1r. Now this just takes patience, especially on a number like 72. And a number like 72, I always try the more obvious one, like 9 times 8. If 9 and 8 doesn't work, then you'd have to go and try 2 and 36. You'd have to try 1 and 72. And 72 actually has a lot of options, like 3 and 24. There's actually a 4 and an 18 hiding in there. There's actually a 6 and a 12 hiding in there. But for most of these problems, it's going to be the one that's what I call on your multiplication tables, like 9 and 8. I need to put the 9 and 8 over here in the right way to get a 25 when I do my O and I. And it's like I said, this just involves guess and check. If I put the 9 there and the 8 there, that'll give me a 18 and an 8. I can only get a 26 out of an 18 and 8, not a 25. So I'm going to reverse these and see what happens. I'm going to put an 8 there and a 9 there. Now that gives me a 9R in the inside and a 16R on the outside, which does give me a 25R. Because it's a negative 25, I need both of these to be negative. Therefore, I need this to be a minus 9 and a minus 8. So this factors into 2r minus 9, r minus 8. You just check it by foiling. 2r times r is 2r squared. Negative 16r and negative 9r is negative 25r. Negative times negative does check. It is positive 72. What I've always said for years is you should be able to do all these problems faster than you could probably do 1 or 2 of these kind. These kind do take a little bit of time, which is why I usually don't give you very many of them, but I need to make sure you understand how to do them. So the answer is 2r minus 9, r minus 8. We have the same situation here. There's no GCF. These guys divide by 2 and 4, but he doesn't. There is no x in all of them, so it's no GCF. It's not a binomial, so it's not a difference of 2 perfect squares. It's a 4x squared trinomial instead of a 1n squared. So in this one, my options are 4r, 1r, or maybe 2r, 2r. Okay. But what's nice is there's only one option for 5, and that's 1 times 5. Okay, I'm just going to try to guess and check a little bit here. With my experience, I can tell that it's going to be this one down here, but I at least want to show that it doesn't always work well for you. If I put a 5 there and a 1 there, that gives me a 5r and a 4r, and there's no way to, I'm sorry, it should be x's, my bad. That gives me a 4x and a 5x, and there's no way to get an 8x out of a 4x and a 5x. If I switch them, now I have a 20x and a 1x, and I can't get an 8x out of that. So basically that's every possibility with the 4 and the 1. So I cross that out, or I ignore that. Now I'm going to try a 2r and a 2r to get my 4. Let's call that a 2x and a 2x to get my 4x squared. Now I'm going to put a 5 here and a 1 there. Now when I do my inside and outside, I get a 10x and a 2x, which I can get an 8x out of. I want the 10x to be negative. I want the 2x to be positive. Therefore, I need to put the minus on the 5. That gives me a negative 10x. I need to put a plus on the 1. Okay? So this answer is 2x plus 1, 2x minus 5. It just takes some trial and error or guess and check on these kind. Okay? So 2x and 2x is 4x squared. Negative 10x and positive 2x is negative 8x. And then positive 1 times negative 5 is a minus 5. Just always FOIL it to check. Okay? So on this side, I gave you a couple of GCFs. I gave you a couple of special binomials. I gave you a couple of what I call easy math games with a 1v squared or a 1n squared. And then I gave you a couple of what I call the harder ones that take a little more time, guess and check. Numbers 14 and 16 will probably take you longer than the rest of the page. I'm going to go to page 2 now. This is what we did the last day, where sometimes things factor more than once. Okay? You always look at the remaining parentheses to see if it can factor again using any of the methods. First, 48 and 3 share a 3 that they can both divide by. So I pull out a 3, and what's left is a 16k squared minus 1. I look at the remaining parenthesis and I say, hey, is that one of the types that factor? Since this is a special binomial, I look and see if it's a minus and if these are both perfect squares. Since it is, the 3 comes down and I break this into 2 more parentheses of 4k, 4k, minus 1, plus 1. This is just like on the front side, numbers 5 and 6. I can split that into 4k minus 1, 4k plus 1, and you bring the 3 down. I didn't have a chance to talk to you about this in class, but it's like in elementary school. Just because you broke that into 2 times 9 doesn't mean you stopped. Because 9 is not a prime number yet, you bring the 2 down. Well, that's the same as bringing the 3 down. And then this is the same as, hey, I got to break that 9 down again into 3 times 3. Well, in algebra, it's the parenthesis you need to look at, and you look at the factoring methods, and this is basically a difference of 2 perfect squares. Number 19, they can all divide by 5. They don't all have a b, so it's just a 5 on the outside. What's left in here is a b squared, a negative 2b, and a negative 15. Now, because this is a trinomial with a b squared, b, and a number, there's a chance it might factor using our math game. So I have to take a moment to check and see, is there something that multiplies to 15 but will add or subtract to 2? My options are 1 and 15, 3 and 5. I can get a 2 out of 3 and 5. To get a negative 2, the 5 would be negative, the 3 would be positive. That's negative 2 when I add, negative 15 when I multiply. So this does factor again. I bring the 5 down, but I split this into b minus 5, b plus 3. Okay, because neither one of those are a difference of 2 perfect squares, that's when you know you're done. Okay? Now, the rest of this page is just a mixture of all of them. Okay? It could be a GCF, it could be a special binomial, it could be an easy math game, it could be a hard math game. Just go through your thought flow chart. Okay, go through your checklist or your thought flow chart. These all divide by 4 and m, so I'm going to pull a 4m out. What's left is an m squared, a minus 1m, and a plus 1. Now, to go along with what we did up here, we look at this and we try to figure out, hey, that might factor again because it has that m squared, m number look. So when I look at this, I say, hey, is there anything that can multiply to get 1, but will add or subtract to negative 1? Well, these only add to 0 and 2, so there is nothing, and I'm done. This one, there is no GCF. It's a trinomial. It's a 1n squared, so I look and see, is there something that multiplies to 24 but adds to 2? 6 and 4 comes to mind. To get a positive 2, I need the 6 to be positive, the 2 to be negative, or the 4 to be negative. And that does give me negative 24 and positive 2. So this factors into n plus 6, n minus 4. Always FOIL and check. N times n is n squared. There's positive 6n. There's negative 4n for a total of positive 2n. And there's my negative 24. This is the hardest one for most people. They assume because it's a binomial, it's a special binomial, but they skip what I call the level 1. Always check for a GCF. It could be a number or a variable. In this case, it's a variable only. They share an x, so I pull an x out, and I'm left with x plus 6. When you pull an x out of this, you're left with x. Pull an x out of this, you're left with 6. Always distribute and check. Okay? So this was a GCF of a variable. Okay? Sometimes a variable can be pulled out. That's one kids miss the most. Okay, this one, they don't share anything, so it's not a GCF. It's a binomial. The only chance I have is if they are perfect squares, and in this case they are. So I break that into 5p and 5p. I break that into -1 and +1. I look at both of those, and neither one of those factor again, so I know I'm done. Okay. And then this one here, we have I look and see if I can divide them all by 5. I cannot. So this is going to be what we call the hard math game. What's nice is the only option for 5x squared is 5x and 1x. There are several options for 60. I'm going to try 6 and 10 first. If it didn't work, then I would try something else like 3 and 20, or I would try like 4 and 15, but usually it's going to be one of the more obvious ones, and this one I can tell it's going to be. To get a 56, I'm going to put the wrong answer first. If I put a 6 there and a 10 there, that'll give me a 30 on the outside and a 10x on the inside, which is not 56. I'm going to switch them, put a 10 there and a 6 there. Now that gives me a 50x and a 6x, which does add to 56x, so I know I'm in the right spot here. This factors into 5x plus 6 and x plus 10. FOIL to check, 5x squared. 50x and 6x is 56x plus 60. Next one, some people might try this up here, but what you're forgetting is always look for a GCF. These guys can all be divided by 5. So I pull a 5 out of all of them. When I pull a 5 out of all of them, I end up with an m squared, a 3m, and a 40. Minus 3m minus 40. Now, because this is an m squared and an m, I need to check and see if it's a math game. Is there anything that multiplies to 40, but will add or subtract to 3? If not, I'm done. However, I notice that, hey, there's an 8 and a 5. If I make the 8 negative and the 5 positive, that would give me negative 40 and negative 3, so this factors twice. I look at the parenthesis, and I apply the math game trinomial type to it, and I do m minus 8, m plus 5. Okay? And then neither one of those factor again because it's not a perfect square. And then the last one, they can all be divided by at least 2. I believe we can go all the way up to 6. These guys can be divided all by 6. Minus 9n plus 20. Now, not knowing your multiplication table certainly hurts you here, but 9 times 6 is 54. And then I might be done, but I need to look at this parenthesis. Since we have an n squared, an n, and a number, it could be one of the math games. So I need to check, is there anything that multiplies to get 20 that'll add or subtract to negative 9? 2 and 10 doesn't, but let's check 4 and 5. If I make them both negative, that would give me negative 9 and it would give me positive 20. So this does factor again. So instead of stopping, I need to split this into two more parentheses of in and in, -4 and -5. Okay. I hope seeing me do 17 problems or all the odds will help you. Now your assignment on Canvas, and I'll attach it to an email as well, is to do the evens and take a picture of them and then turn them in to me by email. If you have any questions, I'm always available by email. I will always be available till 3 o'clock at least. However, I will typically keep checking my email till 5 or 6 o'clock until at least dinner. If you wait and email me after dinner, then I may or may not answer, and I definitely go to bed by 10 o'clock or so. Okay, any questions, please contact me. Thank you, and we will get through this together.